I want to find the derivative of f of x equals 1/2 x minus 3/5. I'm going to be using the definition of a derivative. So that is the limit as h approaches 0, f of x plus h minus f of x all over h. So for every x I see, I'm going to be substituting an x plus h. So I'm going to denote that by putting a parentheses in front. So it's going to be x plus h and then minus 3/5. That's going to be my f of x plus h term, minus f of x would just be 1/2 x minus 3/5 all over h. We can cancel out the 3/5. We have a negative 3/5 minus negative 3/5. Those are going to go away. And then I'm going to distribute out the 1/2 to both the x and the h. I have limit as h approaches 0, 1/2 x plus 1/2 h, and then minus 1/2 x still. So this guy right here. All over h. The 1/2 x, the negative 1/2 x will go away. I'm left with 1/2 h over h. H cancels, and I'm left with 1/2. So the derivative of 1/2 x minus 3/5 will just be 1/2. Next, we'll be looking at a quadratic. So we'll let f of x be 5x squared minus 3x plus 7. I'm going to be looking at my limit as h approaches 0. And here I want f of x plus h. So for every x I see, I'm going to replace it with x plus h. So I like to put parentheses where the x value is. So like the x comes after the 3. So I'm going to put a parentheses after the 3 with x plus h. And then I'm going to be subtracting this with just f of x all over h. So I like to put parentheses and brackets, especially when there's a minus, because otherwise it's going to be wrong. This minus has to distribute to all three pieces. You can't put it as like minus 5x squared minus 3x plus 7. You should always put a parentheses in front. Okay. So what I'm going to do is distribute out the 3, distribute out the negative, and then I'm going to expand the x plus h. So that's going to be x squared plus 2xh plus h squared minus 3x minus 3h plus 7, and then minus 5x squared plus 3x minus 7 all over h. We can cancel out the two 7s. 7 minus 7 is nothing. Negative 3x and positive 3x cancels. And then I'm going to expand the 5 here. So I'm going to have limit as h approaches 0, 5x squared plus 10xh plus 5h squared minus 3h minus 5x squared over h. We can cancel out a couple more things. So we have a 5x squared minus 5x squared. And nothing else cancels at the top, but they all have a factor of h. And that's going to be canceled out by the bottom here. So we're going to have limit as h approaches 0, factor out an h, to get 10x plus 5h minus 3 over h. H's go away. I can plug in h equals 0 for this, and that will just be 0. So I'm left with 10x minus 3 as my limit. So the derivative of 5x squared minus 3x plus 7 would just be 10x minus 3. Okay, next we'll be looking at a radical. So let's say my f of x is 4 minus the square root of x plus 3. I'm going to start with my limit as h approaches 0. And I want f of x plus h. So for every x, I'm going to replace it with x plus h. And we're going to subtract it with f of x, which is the original, all over h. So I have a 4 minus 4. Those cancel. And then I have a minus minus, that's going to become positive. So I can rewrite this as positive square root of x plus 3 minus square root of x plus h plus 3 all over h. If I plug in h equals 0, I'm going to be dividing by 0. So the way around this is to multiply by the conjugate. So let's multiply top and bottom by the conjugate, which will be square root of x plus 3 plus square root x plus h plus 3. In the top, we have a minus b times a plus b. And this will just be a squared minus b squared. So the numerator simplifies into x plus 3 minus x plus h plus 3 all over h times square root x plus 3 plus square root x plus h plus 3. And now we can simplify more. We have x minus x. Those go away. 3 minus 3. Those go away. So I'm left with a negative h, because of this negative and this h. So I can cancel out the h's. And now I can let h go to 0. So what I'm left with is negative 1 over square root of x plus 3 plus square root of x plus 3, which is negative 1 over 2 times the square root of x plus 3. So we conclude that the derivative of 4 minus square root of x plus 3 will be negative 1 over 2 times square root of x plus 3. Last one here, we'll be looking at a rational function. So we'll say f of x is equal to x plus 1 over 2 minus x. So I'm going to be looking at the limit as h approaches 0 of f of x plus h. So for every x, we're going to replace it with x plus h. Minus f of x all over h. Now this is going to get a little messy because I want to get a common denominator here for the top two fractions. So let's see. The 2 minus quantity x plus h can be rewritten as 2 minus x minus h. Okay, so if we distribute out the negative, we can rewrite it like that. So I can, for the common denominator, I'm going to multiply these two denominators. So for this one, I'm going to multiply the 2 minus x minus h. And for the left one, 2 minus x. Okay, let's see how this works. Limit as h approaches 0. So I'm going to distribute the 2 minus x to the x plus h first. that's just going to be 2x plus 2h minus x squared minus xh. And then I'm going to distribute out to the 1 here. So it'll be plus 2 minus x. And then minus, open parentheses. I'm going to distribute the x plus 1 to the 2 minus x minus h. So the x is going to multiply the 2, the negative x, and the negative h. So we get 2x minus x squared minus xh. And then the 1 is going to distribute to the 2, negative x, negative h. So that would just be plus 2 minus x minus h. And here we're just going to zoom out here. So let's try that. Okay. Over the denominator, which will be 2 minus x times 2 minus x minus h, all over h. Okay. Now a bunch of things are going to cancel. So let's see. 2x, 2x, that goes away. Negative x squared, that goes away. Negative xh minus negative xh, that goes away. 2 and 2 go away. Negative x, those go away. So I'm left with 2h minus negative h. So that's just going to be 3h. So I'm going to rewrite this. And by the way, this thing is going to go over here because we're dividing by h, which is the same thing as multiplying by 1 over h. So the h will go there. So I'm going to rewrite it as limit as h approaches 0, 3h over h times 2 minus x times 2 minus x minus h. I'm going to let h go to 0. So this thing goes to 0. The h cancels. Sorry, I should have said first h cancels. So let me correct that. So the h cancels first, and then we're going to let this h go to 0. So we'll be left with 3 over 2 minus x times 2 minus x, which will be 3 over 2 minus x squared. And so we say that the derivative of x plus 1 over 2 minus x is just 3 over 2 minus x squared.